So let's get started. We are going to have a new topic here today, and we are going to build on what we have had on the previous lecture. Today we are going to talk about the addition of coplanar forces. So last time we learned that if we have forces like this, we'll be able to calculate the resultant using the parallelogram law. And if I have more than two forces, the problem is going to be complicated. And also, you can easily make mistake. So we need to have another method which is more convenient than this one. And the new method depends on resolve the resultant into x and y axis. And we are going to call this rectangular components. So if you are going to resolve or decompose the forces into x and y components, we call this rectangular components. And this method, it's more convenient than the parallelogram law and using sine and the cosine law. And in order to make that representation, we can use the scalar notation, or we can use the Cartesian vector notation. First, we are going to start with the scalar notation. So we remember the cosine law and the sine law. And we have a special case when we have triangle and one of the internal angles is right angle, like this one. So C here is equal 90 degree, which is right angle. And in that case, the using the sine law is going to be easier. So we are going to say A over sine A equal B over sine B equals C over sine C small. But C small here is equal 90, and sine 90 equal 1. So in that case, if we have right angle, we are going to say A equal C multiplied by sine A. Or if you want to calculate B, then we are going to say B equal C multiplied by sine B. So the formula here is going to be reduced. It's going to be easier. That is why we are going to decompose the resultant force into rectangular components, because using that formula here is going to be easier. And in order to do that, we need to remember the sign convention. The sign convention means if this one should be y and this one should be x. So we have a mistake here. So the x, if you are going to that direction here, right direction, the value of the force is going to be positive. And if you are going to go to that direction, the value is going to be negative. The same thing for y. If you are going to go in that direction, the value is going to be positive. If you are going to go to that direction, the value is going to be negative. It's very important to remember this. So here, since we have C, A, and B, and here we are going to use the scalar notation, which means that we are going to deal with rectangular components. So the triangle here is similar to that one, which means that the angle here is going to be 90 degree. So if I have F, resultant force F, I need to decompose that force into X and into Y. Now the problem is going to be very easy. In that case, directly, I'm going to say that the value of Fx and value of Fx is similar to A. And value of F is similar to C. and the value of Fy here is similar to B. Since the angle here is right angle, then I'm going to say that the value of B equals C multiplied by sine B. So we say that instead of B, here it's represented by Fy. So Fy is going to equal F. Instead of C, I'm going to put F. Instead of sine B, I'm going to put sine C. Because B is opposite to, B small is opposite to B capital. The same thing, I'm going to say that I need to calculate the value of A. The value of A here is the value of Fx. And the value of Fx is going to equal the value of C. C is represented by F multiplied by sine A, this angle here. But if you do remember the trigonometry, if this one is 90 and this one is, let's say this one is phi, the angle here should equal 90 minus theta. And sine 90 minus theta is equivalent to cosine theta. So instead of writing sine 90 minus theta, we are going to put it like that, cosine theta. So how I'm going to differentiate between the sine and the cosine? I have simple rule in order to not to be mistaken. So if this one is the resultant and if this one is the theta here, the resultant here is going to lie. If you let it to drop, it's going to lay here. So where you lay, you are going to multiply by the cosine. The other one, it will be multiplied by sine. So this is very simple rule in order to use it. And also, I could use the proportional length. Sometimes they don't give us the angle. They give us the proportional length. And also we need to learn how to decompose the F into Fx and into Fy using the proportional length. The proportional length, it's mean that the ratio, for example, between A and C is going to be similar to Fx and F. Why is that? Because this one just a small triangular and this one is a bigger triangular, but the ratio between them are the same. Then in order to know the value of Fx here, we're going to say that Fx is similar to A. This one horizontal line and this one is horizontal line. And the value of C, this side here, is similar to F. So I'm going to say that Fx over F is going to equal to A over C. The ratio between Fx and F is similar or equal the ratio between A and C. And also, you could say that Fy, which is this one, Fy is similar to B. So Fy over F is going to equal B to C. Then to calculate the value of Fx, I will say that Fx equal F multiplied by A over C. And Fy is going to equal F multiplied by B over C. But here we have a minus, like you can see. So from where we get that minus? Here, like you can see, the direction is down. And according to the sign convention, since this one is down, that means the value should be minus. If it was up, then it will be positive. Because if the force in that direction, it will be decomposed into positive x and negative y. If the force was here in that quarter, then it will be decomposed into negative x and negative y. If it's here, it will be decomposed into negative x and positive y. Any question here so far? Do you have any question right now? Is it clear for all of you? Okay, let's move on. Now we talk about the scalar notation. Also, we are going to talk about the Cartesian vector notation. We have two methods in order to express the rectangular components. In this method, the x direction is going to be referred by the letter I. So letter I means the force is in the x direction. I is the something called unit vectors of x direction, and y is the unit vector of the y direction. So if I have a vector like this one, and I decompose it into x and y, I'm going to say that f equal fx, where fx is the magnitude in that direction. I refer to the direction of the force, and here is going to be plus fy. Fy is the component into y direction, and j is the direction for the y. So when I write it like that, this one called Cartesian vector notation. And of course, when we write something like that with a bold font, it means that we are dealing with vector. When we write it like that with the italic font, it means its magnitude. And that formula, it could be applied to any type of plane. The plane could be complicated, like this one. You have x, you have y like that. X here is positive, and y here is positive, which means that y here is negative. If I have a force in that quarter, that means it will be decomposed here and decomposed here. In the x-axis, the component is going to be positive. In y-axis, the component is going to be negative. So I'm going to say that f dash, the resultant force, is equal fx, the component in x direction, multiplied by I refer to the direction, plus f x here, or fy here, f dash y, multiplied by minus j, because the direction is in the negative direction. So fx and fy represent the magnitude, and plus or minus I or j represent the direction. So now, if we have f1, f2, and f3, and we need to find the components. So I need to decompose the forces into x and into y, like you can see here. But if I have f1, if I'm going to use the Cartesian notation, f1, it will be f1x, the component in x, multiplied by I, plus f1y, the component into y, multiplied by j. This one is positive and positive, because this one is a positive direction and this one is the negative direction. And also I have f2 here. It's going to be decomposed into negative x and into positive y. That is why f2 equal minus f2x I plus f2y j. Then what about f3? f3, it is going to be represented by f3x, the component in x direction, and here is positive, and it's going to be represented by fy, f3y, which is negative, because this one is the negative direction. Now, how I'm going to calculate the resultant for that case? We know that the vector fr is equal to vector a plus vector 2 plus vector f3. So fr equal f1 plus f2 plus f3, and all of them are vectors. Then I'm going to put all the components like that. And then I'm going to find this one with I, this one with I, this one with I, this one with j, this one with j, this one with j. I'm going to take I as a common factor here. I'm going to sum all the components of I. I'm going to put them together. The same thing, it will be done for j. I'm going to put all of the components of the j together. Then instead of writing all the component in x direction, is going to be referred by frx, which means that the resultant in x direction. And all of this is going to be represented by fry. It's mean the resultant in the y direction. So frx represent f1x minus f2x plus f3x, and fry represent is going to equal f1y plus f2y minus f3y. So frx is the summation of the forces in x direction. This one is positive, this one is positive, this one is negative. And fry, the components into y direction. This one is positive, this one is positive, and this one is negative because this one is down. If you are going to use the scalar notation, after you decompose into x and into y, frx is going to equal f1x minus f2x minus f3x. And regarding the fry, we are going to have f1y, f2y minus f3y. Here I think he's made a mistake. This one should be positive because f3x is positive. So I think this one is the mistake here. And the same thing, it could be represented by Cartesian vector notation, like we just explained here. So you could write the components by using the scalar notation or by Cartesian vector notation. The Cartesian vector notation is very important because next time, in the next lectures, we are going to face problems that cannot be solved by the scalar notation. It's going to be very difficult to do that. It's easier to use the Cartesian vector notation. Then, in order to calculate the resultant force, if I have F1, F2, and F3, I decompose them into X and Y, all of them. Now I need to calculate the magnitude of the resultant. Since we have right angle, the cosine law, remember in the cosine law, we used to have that part. But when this one is 90, then this one is going to equal 0. So now Fr equals the summation of Frx square plus Fry square. Now I put the summation of the forces in x axis here, Frx, and the component F, all the forces in y axis in Fry. Then in order to calculate the resultant, it's going to equal the square root of Frx square plus Fry square. And in order to calculate the angle here, the angle is going to equal tan inverse of Fry over Frx. And by this, I will be able to calculate the resultant force and the angle with the x-axis. We used to do that by using the parallelogram law, maybe more than one time, and then either to use the cosine or the sine. Now we have a procedure for that. And like I said, this procedure is more convenient. So let's see example here so that we can understand what we have mentioned before. So now I have F1 and I have F2. We need to determine the X and Y components. So they ask us to calculate the component in X and component in Y for F1 and for F2. And also, they want us to express each force as Cartesian vector. Let's see how we are going to handle this. First, we need to remember the X and Y direction, which one is positive, which one is negative. Then draw X and draw Y. First, we are going to put F1. And I need to calculate the X and Y components for F1. So F1, we are going to have F1x is going to be in this direction. And this direction is negative. So that value is going to be negative. And also we are going to have Fy component. And this one is going to be positive. And we'll learn how to know the value since we have the angle here. So now we need to calculate the value of F1x. I have the angle here. Like I said, whenever you have the angle, that means the component here is going to be multiplied by the cosine. And the other one is going to be multiplied by the sine. So in that case, F1x is going to equal F1, which is 200, multiplied by sine 30. This angle here. So we are going to use the scalar notation. And the value of F1x, this one, of course, is going to be negative because it's opposite to that direction. That direction is positive. This one is negative. And it's going to be multiplied by F1 here, which is 200, and then multiplied by sine 30. And it's going to be, of course, Newton. And if you multiply this one, the answer is going to be minus 100 Newton. And if we are going to use the scalar notation, I need to put the direction. I can take the minus out and put the direction. It means the same thing. Because here you show us the direction of the force. Here minus, it means that it's in the opposite direction. So after you put the minus, you can take it out and put it like that. Also, we can calculate F1y. F1y is going to equal F1 multiplied by cosine. Like I mentioned before, I'm going to use this as a simple rule for that. So F1y is equal 200. Of course, this one is positive because this direction is positive. Multiplied by cosine 30. And if you multiply this, you are going to have 173 Newton. And the direction is like that. Also, regarding the second one, which is F2, this time he didn't give us any angle. He gave us the proportional length. And F2 is going to be decomposed into F2x, this one is positive, and into F2y, this one is negative. And in order to use the proportional length, like we just said, we will say that if I want to calculate F2x, this direction, so this one is horizontal, I'm going to say that F2x over F2 is going to equal 12 over 13. Because 12 is horizontal like F2x, and 13 is like a inclined like F2. So in order to calculate F2x, I will say F2x over 260, which is F2, is going to equal 12 over 13. Then I will put this to the right hand side, and F2x came out to be 240 Newton. I can do the same thing with F2y. So similarly, F2y is going to equal 260 multiplied by 5 over 13. So the only difference is here we have 12 because this one is horizontal. This one is vertical. Then I will put 5. And after I finish, I need to put the direction like that, and here the direction is like that. And if I'm going to express, now I finish the first part. I decompose all the forces into rectangular components. And also he says that he wants us to express each force as Cartesian vector. We remember that F1 as a vector is going to equal Fx, and we already calculate Fx, which is 100, and we have a minus here because the direction is opposite, multiplied by I. Indicate for the x direction, plus, yeah, we should put F1y, and we already calculate the value, so we'll put it like that, multiply by j. J indicates to the y direction. Regarding F2, we have Fx2, F2x, 240i minus F2y, and it's minus. We calculated here, minus 100j. J indicates for the y direction, and it's negative. So here we can see the whole pictures. Here we have F1, decompose it into F1x. Here the value of F1x. Here is the value of F1y. The same thing for F2. Okay, do you have any questions regarding this example here? Finish the lecture. We have a screw eye like this one, and it's subjected to two forces. We have F1 and we have F2. F1 equals 600 Newton and F2 equals 400 Newton. And he gave us the angle here and the angle there. We need to determine the magnitude and the direction of the resultant force. We need the resultant force and we need to know the direction. Of course, this problem, it could be solved using the parallelogram law and then followed by sine and cosine law. But here we are going to use the rectangular components. We are not going to use the parallelogram law and sine and cosine law. So also we need to remember the sign convention. This one is positive, this one is negative. We say that this one should be x and this one should be y. I'm going to draw x and I'm going to draw y, and I need to know this one is positive, and negative. We'll start with F2. F2 equal 400. So it's going to be decomposed into that direction here, which is negative. We are going to call it F2x. And into that direction, F2y, which is positive. And also, I'm going to decompose the F1 also into x and into y. Into x, of course, is going to be positive because this direction is positive. And into y is going to be positive as well because this direction is positive. Now I need to know the value of F2x. In order to know the value of F2x, I need to know the value of F2 and that angle. And we know that F2x is going to equal F2 multiplied by either sine or cosine. In that case, since the angle is here, then F2x is going to be multiplied by the sine. So F1x is going to be equal 600 cosine 30 degree. So he starts with this one, sorry. He starts with F1, not F2. So no problem, we'll move to F1. So in F1, F1x is positive and this one is positive. And he gave us the angle here. Since the angle is located here, then the component into x is going to be multiplied by cosine. So F1x equals 600 cosine 30 degree. Regarding F2x, F1y, this one also is going to be positive, but it's going to be 600 multiplied by sine 30. This one is cosine and this one is sine. Now let's get back to F2. It says that F2 is going to be decomposed into x and into y, into F2x and F2y. This one is going to be negative and is going to be multiplied by sine 45. So F2x is going to be minus 400 multiplied by sine 45, and F2y is going to be positive. It's going to be 400 F2 multiplied by cosine 45. Of course, in case of you have 45, sine and cosine are the same. Even if you made a mistake, the answer is going to be correct. Now we decompose all the forces into its rectangular components. Now I need to calculate the resultant force. First, I need to calculate the resultant into x and then calculate the resultant into y. So in order to calculate the resultant into x, we are going to consider any direction in here is going to be positive. Then frx is going to equal 600 cosine 30, which is this one, f1x minus f2x. So frx equal f1x minus f2x. We already know this one and we know that one. And the answer came out to be 236. And remember, the resultant into x came out to be positive, which means that in that direction. So also we need to calculate the resultant into y direction. I'm going to take this one and that one together, and this one and that one. Of course, this one is positive and this one is positive. So the direction, of course, is going to be positive. So summation of the forces in y direction equal F1y and F2y. And of course, the direction is going to be positive. This one you cannot know the answer unless you solve the problem to know the new direction. And now we have the resultant into x and resultant into y. I need to know the location of the resultant because this one is very important. So always show the direction arrows when you're using scalar notation. Since we are using scalar notation, it's very important to know the direction of the arrow here. Like you can see here, the resultant into x came out to be positive, and the resultant of the force in y came out to be positive. That means the resultant is going to be located in the first quarter. And it's very important point to know that. Then we are going to calculate the resultant is going to equal square root of summation of x square plus the summation of fry square. And here is the answer. Also, I will be able to calculate the direction here with the x-axis. The direction is going to equal tan inverse of summation of fy over the summation of ry, the resultant in y over the resultant in x, and that it will give us the angle here. Of course, many tricks it could be done for the problems in order to make sure that the student understand the lecture correctly or the problems correctly. Many tips and tricks it could be used here. So my advice to you again, you need to solve this problem by yourself again until you master the problem. Sometimes you feel like you understand the problems, but unless you solve it by your own hand more than one time, you will not be able to completely understand what's going on. Okay. So any